Hey everyone, welcome back to Codebreakers. If you're new here, be sure to hit that subscribe button and ring the notification bell so you don't miss out on our latest programming and hacking content. Today, we're diving into something that every Python developer has encountered at some point, common mistakes that beginners make, and more importantly, how to avoid them. Whether you're just starting out or brushing up on your Python skills, this video will help you steer clear of some of the most common pitfalls in Python programming. We're talking about those little errors that can really trip you up, especially when you're first getting started. But don't worry, I've got you covered. I'm going to break down each mistake, explain why it happens, and show you exactly how to avoid it. So, let's get started. First up, we have indentation errors. Now, if you're coming from other programming languages, this might seem a little strange at first. Unlike languages like JavaScript or C++, which use curly braces to define blocks of code, Python relies on indentation. Yep, you heard that right, indentation. In Python, the way you indent your code actually affects how the code runs. This is because Python uses indentation to figure out which lines of code belong together, like inside a loop or a function. So if you're not careful with your spaces and tabs, you're going to run into some problems. For example, let's say you're writing a simple for loop to print out numbers from 1 to 5. You might be tempted to just hit the spacebar a couple of times to indent the line of code inside the loop. But if you're not consistent with the number of spaces you use, Python's going to get confused and throw an error. The key here is consistency. Pick a style, whether it's 2 spaces, 4 spaces, or a tab, and stick with it throughout your entire code. Trust me, this is going to save you a lot of headaches in the long run. Now, most modern code editors and IDEs are smart enough to help you out with indentation. They can automatically insert the correct number of spaces when you hit the tab key, and they can even highlight any inconsistent indentation for you. So make sure you're using a good code editor and take advantage of these features. But even with these tools, it's still important to understand how indentation works in Python. It's a fundamental part of the language, and once you get the hang of it, it actually makes your code more readable and organized. This next one is a bit more subtle and can really trip you up if you're not careful. We're talking about mutable default arguments and functions. Now that might sound a bit intimidating, but stick with me. It's not as complicated as it sounds. In Python, you can define functions with default values for arguments. This is really handy when you want to make your functions more flexible. But there's a catch when it comes to using mutable objects, like lists or dictionaries, as default arguments. Let's imagine you're building a game, and you have a function that's supposed to add a new item to a player's inventory. You might be tempted to define this function with an empty list as the default argument for the inventory. The problem is, this default list is only created once when the function is defined, not every time you call the function. So, if you call the function multiple times and modify the inventory, those changes will persist across all calls to the function. This can lead to some really unexpected and hard to debug behavior. The solution here is to use the special value none as the default argument instead of an empty list. Then, inside your function, you can check if the inventory argument is none. If it is, you create a new empty list. This way, you ensure that a fresh, empty list is created every time the function is called, preventing any unintended side effects. Alright, let's talk about files. Working with files is a common task in Python, whether you're reading data from a file or writing data to one. And when you're dealing with files, it's super important to remember to close them properly when you're done. Think of it like this. Every time you open a file in Python, you're basically asking the operating system to reserve some resources for you to work with that file. If you don't close the file when you're finished, those resources stay locked up, and this can lead to problems. For example, if you have a program that opens a lot of files without closing them, you might eventually run out of system resources, causing your program to crash. Or worse, if your program crashes before it has a chance to close a file, you could end up with corrupted data in that file. Now, you might be thinking, okay, I'll just make sure to call the close method on every file I open. And while that's definitely better than nothing, there's a more elegant and foolproof way to handle files in Python, the with statement. The with statement in Python is like a superpower for working with files. It creates what's called a context, and within this context, you can work with the file however you need to. The beauty of it is that once you're done and your code exits the with block, Python automatically closes the file for you, even if an error occurs. Chapter 4. Confusing IPsys and ISOs operators. This next one is a classic, and I guarantee almost every programmer has fallen for this one at some point, especially when starting out. I'm talking about mixing up the assignment operator, ISO, with the equality comparison operator, ISISIOS. It's an easy mistake to make. You're cruising through your code, feeling like a coding ninja, and then bam! You get an unexpected result, and you can't figure out why. Often the culprit is a single equal sign, iki, where you should have used two, ISISOS. Remember, in Python, a single equal sign, ISIS, is used to assign a value to a variable. It's like saying, hey, variable x, from now on, you're equal to 5. On the other hand, the double equal sign, ISISIUS, is used for comparison. It's like asking, hey, are these two things equal to each other? So if you accidentally use a single equal sign when you meant to compare two values, you're essentially changing the value of a variable instead of checking if two things are equal. This can lead to some really sneaky bugs that are hard to track down. The best way to avoid this mistake is to be super mindful of what you're typing, especially when you're dealing with conditional statements like if and while loops. Double check your comparisons, and if something doesn't seem right, chances are you've got an assignment A where you need a comparison. ISISIOS. Chapter 5. Incorrect handling of import statements. Alright, let's talk about import statements. Imports are what allow you to bring in code from other modules and libraries, which is one of the things that makes Python so powerful and versatile. But as your projects grow larger and you start working with more complex structures, imports can become a bit tricky to manage. One common mistake is using relative imports incorrectly. Relative imports are when you import something based on its location relative to the current module. This can be convenient when you're working within a package, but it can also lead to confusion and circular import issues if you're not careful. Here's a simple way to think about it. Imagine you have two friends. Let's call them Module A and Module B. Module A wants to borrow something from Module B's house. Now Module A could give directions based on its own location, like go 2 houses down and turn left. That's kind of like a relative import. But what if Module A moves to a different neighborhood? Those directions wouldn't work anymore. That's the problem with relying too heavily on relative imports. If you move your modules around or change your project structure, your relative imports might break. A more robust solution is to use absolute imports whenever possible. An absolute import is like giving the full address of Module B's house. It doesn't matter where Module A is located. It can always find Module B using the full address. Chapter 6. Misunderstanding scope and variable shadowing. Our final common mistake for today is misunderstanding scope and variable shadowing. Now, this one might sound a bit technical, but it's an important concept to grasp, especially as you start writing more complex Python programs. In the simplest terms, scope refers to the lifetime and accessibility of a variable within your code. Think of it like different rooms in a house. Each room has its own set of objects and furniture that are accessible within that room, but not necessarily in other rooms. In Python, functions create their own local scope. Any variable you define inside a function is only visible and accessible within that function. It's like having a private storage space within that function. Now, here's where variable shadowing comes in. Let's say you have a variable defined outside of any function. This is called a global variable, and it's like having something in the common area of the house, accessible to everyone. If you then define a local variable with the same name as a global variable inside a function, you're essentially creating a shadow copy of that variable within the function's local scope. Any changes you make to the local variable will only affect the shadow copy, not the original global variable. So, those are some of the most common mistakes that beginners make in Python, and now you know how to avoid them. By keeping these tips in mind, you'll be able to write cleaner, more reliable code. But hey, we've all been there. Everyone makes mistakes when they're learning something new, and Python is no exception. Have you encountered any of these issues before? Or maybe you've got a different Python mistake that tripped you up when you were starting out? Share your experiences in the comments below. I'd love to hear your stories. And don't forget to like, subscribe to Codebreakers, and hit that notification bell so you stay updated with all our new content. Thanks for watching, and I'll see you in the next video.